So yesterday we were reviewing all of our logs. And that's what we're doing again today for a quiz tomorrow. So I kind of have this handout broken up into the types of things that are going to be on your quiz. You know, first we have just going back and forth. These are just a definition thing.
Were we supposed to turn in our thing from yesterday?
Yeah, I collected them.
You should wait a second because I have no internet.
Okay. So you had problems like these yesterday on the review that we did. And it's really just a matter of remembering that definition. So you always start with your base, whether it's base of the exponential or the base of the log, and then we just go around the equal sign. So if I want to write number 1 as a log, what would I put?
B to the...
Log.
Oh wait, hang on a second. I was like, it was already written.
To be log base.
What the...
You always start
I'll say
the base
log.
of the exponential and the base of the log are the same thing.
Is it to 3.7?
3.7 equals 5. So the log is always equal to that exponent. So number 2, I'm asking you to go the other way. So if you change this to exponential form, you start at the base. I'm drawing those arrows. So it would be to the equals. That's the first couple questions on the quiz tomorrow. One of each of those, just the definition. I didn't put one on this review, but maybe I'll do one as an example. If I just ask you to evaluate log base 3 of 1 over 27. When I ask you to evaluate that, we're figuring out what it's equal to. We had some yesterday, there was a station over there that had problems like this. What did we have to do?
You can set it equal to x first, right?
So then if we change that to an exponential,
3 to the x equals... And then make the bases the same.
So I can't really change 3 to the x. How would we change 27?
3 to the negative 3.
So then x is negative 3.
One of those will be on the
Mhm.
quiz tomorrow? Okay.
So I'm kind of looking at the quiz as I'm talking about what's going to be on it. So I've done, like, basically those are the first 3 questions. You're going to have 2, one where it's an exponential, write a log, one where it's a log, write an exponential, one with just evaluate. We can find domains of logs. I don't want to work all of these with you, but I want to kind of run through examples to help you. So if I ask
Are the
you,
examples from the thing or get a different paper?
I'm just kind of making these up. So it's up to you if you write these examples down. The ones I'm doing right now are not on there. I did the first 2 questions for you, then I kind of went off on a tangent. So these are like problem number 7 on your quiz, or sorry, on your homework. There'll be one on the quiz. If I ask you to find the domain of a log, if you're finding a log, what do we have to do?
To make it greater. What is it? X has to be greater than... I don't remember.
Whatever we're doing the log of. So 3x plus 4 has to be a positive number, so greater than 0. So 3x has to be greater than negative 4. Divide by 3, so x is greater than negative 4/3. How would we write that in interval notation? So the calculation itself isn't too difficult there, it's just a matter of remembering that when you're doing the log, it has to be greater than 0. Okay. So I will ask you to solve some equations on your quiz, which is like problem number 4, just change them to exponential form, and then those are like equations we had on our last test. We'll have to expand and condense and graph. So let's just talk about a little bit with each of those, and then I'll leave you guys to try some problems. Problem number 3. When I ask you to graph,
Are we doing one from the thing?
yeah, I'll do one from there. Okay. So when I ask you to graph these,
I have a quick question.
yeah.
So,
When you graph exponentials, I'm always going to tell you you have to have at least 3 points. So we always plug in 3 points for the exponent. What variable is my exponent? X. So I'm going to put in -1, 0, and 1 for my x. So 2 to the -1 power. What does a negative exponent do? So that would be 1/2. 2 to the 0 power is 1, and 2 to the first is 2. You don't need to make this dash, I just did because I'm going to use it here in a second for something else. So this is my 2 to the x. You can certainly use your graphing calculator to double check it, but I will require some exact points, so make sure you know how to get those. So if you're looking at problem 3, I have A through G. You don't necessarily have to make that many, 7 different graphs. You can do some of them on here. A is going to be your parent functions for B and C. So if you want to draw B and C on the same graph, you can. For B, when I say y equals -2 to the x, what does a negative out in front do? Like making your y's negative. So if I flip this over the x, so if you want to do that on there, you are welcome to. Please keep those 3 points, so just think about the transformations there to get them. So you can do C on the same graph. When you get to D through G, you'll need a second graph for that log. All right, why don't I give you guys a little bit of time to work right now and see what questions